Okay, so SSH is how we log into our various servers. And SSH does provide a way to do password authentication, but we almost never use it. We instead use it's not ASICs. Anyways, we use public and private keys. What? To authenticate with our servers, so we can log in. Now, this is also how you authenticate with GitHub to push up code. When you are on a new machine, you need to create your kind of personal key, and these are kept in home.ssh folder. There is, right now, the standard is to use RSA. And here's two keys. I'm going to have to recreate my key after this. So that is a private key, and that's a public key. So the private key we want to keep protected and safe, but the public key is what you assign to or to install on servers and services like GitHub to authenticate with these servers. The way authentication happens is you try to initiate an SSH connection. For example, like this one. And when you do that, the server takes the public keys, generates a random string, encrypts that random string with the public key that it has for that specific user, and sends the random string back to you. If you have the corresponding private key, you can then decrypt that random string and send it back to the server, thus proving that you are the person who holds that corresponding key. Go through that process as we're logging in, and then we'll set up a shell and run whatever commands you need to. Our deployment scripts use this as well. Now there are various kind of problems we run into, or issues we run into while using keys. When keys are generated, they can be encrypted on the disk so that when they're at rest, they're not in the form that's usable if someone were to gain access to your drive. And for them to be usable, they have to be decrypted and then loaded into memory. This is done through the program that manages this is the SSH agent. And you add keys using SSH add. First thing you can do is you can list and see what keys are loaded into your keychain. If you want to add a key, you just do SSH add and you specify the path for the key. Don't specify a path, it will use the default path of .ssh ID RSA. Now, because my key is encrypted, it popped up. I type in my passphrase. You only have to do that the first time you log into your machine. And that key will stay loaded in your keychain, and you can SSH in the servers without having to type a password. Now, a key can also be created that doesn't have a passphrase on it. And if you create your key with that without a passphrase, and you SSH into a server, SSH is able to load that key and use it without having it loaded in the SSH agent. However, if you use SSH Forwarding, and SSH Forwarding is where you log into one server and then you kind of hop to log into another server. We do this when we deploy to GitHub. What happens is we log into the server and then we log into GitHub and pull down the code or updates to the code and go through the rest of the deploy process. So if your key does not have a passphrase on it, you can log into servers without loading it into the keychain, but you cannot do SSH forwarding. So if you are trying to deploy and you are able to deploy but not to connect to GitHub, it is most likely that your key is not loaded in the keychain. Even if you're able to connect to GitHub locally, you still need to add it to the keychain. And to do that, you can use SSH add and then pass the key. There are the two other important files inside of the SSH config directory are known hosts, config, and on servers there's some additional authorized keys. So if we look at SSH known hosts, it is a list of all of the servers that so when you SSH in the server for the first time, it will come up and show you a fingerprint of the server. And this is how you can verify out of band that the server you're talking to is legitimately who you think it is. And once you accept that fingerprint, it will be stored in your known host file. And from then on, that check will happen automatically. This is done so that if someone were to attempt a man-in-the-middle attack, you will be able to detect that attack. Authorized key file is just a list of keys that are allowed to log in as you into a machine that is running the SSH daemon. And then the .ssh config file has various settings in it that you can use. So it has an entry for hosts, and it can have wildcard entries. And because our SSH servers change somewhat frequently, I added this strict host key checking and user known host file to dev null, so that they're not saved in my known hosts all the time. And I have it set up for localhost that way because I do a lot of tests with vagrant, and whenever you bring down and then restart a vagrant instance, it regenerates the key. It would have to be reaccepted or removed and reaccepted every time. Probably the other, and then the star is basically applied to all hosts. And the most important one is forward agent yes. That means I want to forward my agent to pretty much all hosts. In some situations, you may not want that to be the case, but in our servers we log into, we want to forward all of ours. Further things you can do is you can add entries so that you can SSH into a server with a very short command line. Just say host foo. You can specify a host name. Remember that, right? Let's see. I have to look up the exact syntax later. You can specify host name, username. You can specify a key on your local drive to use, and then from then on, you can just SSH foo, and it will log in to that specific machine. Right, so it's actually capitals. So if you are adding a host entry, you can look up the exact syntax. Any questions?
I don't know if you touched on this already, but you might mention the fact that when you reboot, all of the keys you've added to your agent are emptied and so you need to. So talk about how you handle that.
So if you have a passphrase on your key, you just SSH add at the very beginning. So if you reboot, it does clear all your keys. And so after you reboot, you just have to do SSH add to add your local key. And otherwise, if you had a key that didn't have a passphrase, you can add a line to your bash or C. And just to say SSH add C, and it will load it every time you start it. If you happen to ever share keys on Dropbox, Dropbox does not transfer permissions. And so if you have a key that has had its permissions messed up, SSH will refuse to load it unless it has 600 permissions. So you just change mod 600. And if your .ssh folder gets messed up, that's change mod 700.
So do you always recommend putting a password on your SSH?
Yeah, it's just kind of standard practice. And if
what does that?
I forget to add it the first time, and it comes up and says permission denied, and then I just always SSH add shell. It reminds me that it is or is not loaded, and then I go ahead and load it.
So what protection does that actually give you?
If you're searched by a border, if your laptop is seized by a border agent, if it's ever, so basically make sure that it is never written in an unencrypted form to a hard drive, so that if it's ever either shared users were to compromise your or your key, or I guess it protects you from like shared users on a machine, or from.
So how do you remember all of your key passwords?
I only have one.
Oh, okay, that's going to make it easier for me to attack. I'm just teasing, sorry.
So I have, as far as remembering passphrases,
Now, I'm just kind of poking a little bit, teasing you a little bit because, you know, part of why we use the keys, right, is so that we don't have passwords. But I guess the situation where someone was trying to attack your key password, that's not as easy to do, right, as
Yeah.
to attack a server.
Right. Using key authentication is basically really, really hard. Like, you know, guessing a password, you can just brute force it. But the kind of the random string that's generated and then encrypted and sent to you to decrypt, you don't really know. Even as an attacker, if you somehow guess the right key, it's so large that the key space is huge. It would be very, you wouldn't even know you decrypted it correctly because it's just a random string. But then kind of having a passphrase on your key locally keeps, kind of prevents various attacks of like other people on your computer or remote access from just being able to maybe copy files, or if you accidentally copy to a backup or anything like that, it prevents it from being able to be used by other people because they don't know who that is. So, also, when you load it into the key agent, in its decrypted form, the key agent locks the memory page so that it's not written to disk. For hibernation. So, let's see. So, Dropbox and the transfer permissions. This applies not just SSH keys, but other things. You can change permissions in Dropbox. Just make sure they're loaded into your keychain. Let's think that any other questions? It seems like there's something else I was going to mention. I'm going to add there's a Capistrano SSH Doctor task that lets you kind of run it and make sure things are set up correctly and make suggestions about things you can change. So it'll check and make sure permissions are set up correctly and all that.